Hi, folks. I've been looking forward to this section for a long time. This is section G from Algebra 1 for IXL, and this is about coordinate geometry. And this is section 4. It's the last section in this part. But I want to caution you that I'm going to be using the slope formula. And more than that, I'm going to be using my shortcut for the slope formula in order to find the distance between 2 points. Now, of course, I'm going to explain it, but it's not the same as if you can actually do it yourself. So I hope that you will actually think about, you know, uh, going ahead and looking for the slope between 2 points, watching my shortcut video, and then coming back to this one. Coordinate geometry, the distance between 2 points is so many connections that I'm probably going to overteach it, but this is my first time seeing it on this section. So we'll take a look and hopefully it'll be fun. It's working. There it is. Okay, so I'm going to go ahead and do a graph like I sometimes do. Um, but I guess before I do that, I'm going to go ahead and just write the formula that you all are probably familiar with. The formula for the distance between 2 points. Now remember, this is x1, y1, x2, y2. There are two different points here. And so there are two different x's. And so we sometimes, I guess it's not letting me write up there very well. Let me put it underneath for you. So this is x1, y1, and this is x2, y2. These little numbers down here are called subscripts. They have nothing to do with exponents. They have to do with how identifying different x's. You see, x1 is 8 and x2 is 2, and y1 is 9 and y2 is 1. And we also use these subscripts when we're doing the slope formula. Now, what I'd like you to do is take a look at the slope formula too, but let's start with the distance. The distance formula is equal to the square root. Don't worry, it's not that scary. Most people write it in this order: y2 minus y1 squared plus, sorry, x2 minus x1 squared. Now, if you were to look this up in the textbook, you're going to see that they start with the x's first. Now, the reason that I start with the y's first is because the slope formula is y2 minus y1 over x2 minus x1. And you might be able to see why it is that I want to do the slope before I do the distance formula. And I'm going to show you the connection between them. But there's a very clear connection. The y2 minus y1 is right there. The x2 minus x1 is right next to it. And we are going to use those numbers more than once. A lot of times it's important to find not only the distance between 2 points, but also their slope. And especially when you're evaluating or looking at geometric coordinate geometry. So anyway, here they are. I'm going to go ahead and put them in the distance formula, and then hopefully you'll be able to see the connection later. Now, a lot of people are perfectly happy with just simply being able to do it, which means that you just substitute the values in. So I'm going to take the difference in the y's, which is 1 minus 9. And I'm going to take the difference in the x's, which is going to be the 2 minus 8. A lot of people get excited because 1 minus 9 is a negative and 2 minus 8 is a negative. It doesn't matter at all for distance formula whether you get a negative distance or a positive distance, because you're going to end up squaring it anyway. So the distance is equal to the square root. This is negative 8 squared. It is very, very important that you keep those parentheses, because negative 8 squared is not the same as negative 8 inside parentheses squared. There's a difference. So easy to make a mathematical error there. This one is -6 squared. And I can tell you already that the distance is 10. That's called a Pythagorean triple. And we'll be doing with those later. Anyway, this is 64 plus 36, because -8 times -8 is 64. -6 times -6 is 36. And we have the square root of 100. And the square root of 100 happens to be 10. So these points have a distance of 10 units. Now, before I move on, I just want to point out something. One of the things that I tell my students all the time is if they can find the slope and don't reduce it, that they can find the distance in their head. And I promise this is true for most cases. And if I take y2 minus y1, which is -8, x2 minus over x2 minus x1, which is -6, my slope is 4/3, but be careful. This is the same as 8/6. We don't want to reduce it. The whole point is that I can use this number right here, and I can use this number right here. And squaring these, 64 plus 36 is 100, and taking the square root gives me 10. Now the slope, of course, is 4/3 when you reduce it. But remember, don't reduce it if you're going to use it in the distance formula. Anyway, there's a lot of stuff going on there. Hopefully I didn't overdo it too much. We'll go on to another one. Now, just so you can see that I can actually do it in my head, this is going to be 16 and 9 is 25, so the distance is 5. What I did was I found the slope in my head, squared them both, added them, and took the square root. Basically, I'm going to go ahead and use the distance formula one more time. The distance formula is the square root of the difference. Now, sometimes you're going to see it written like this, just so you know that it doesn't matter if you do the x's first. It's just I always do the y's first because that's the way they appear in the slope formula. And I like making connections in math. Anyway, x2 minus x1 is 7 minus 4. Don't forget, a lot of people leave the square root off until the very end, and it needs to be there. And maybe I'll do a little lesson on where it comes from after we get a little further along. This is 4, y2 is 4, y1 is 0, and we're squaring it. And we have the square root of 3 squared plus 4 squared. And by the way, this is a 3, 4, 5 Pythagorean triple. For those of you who've never heard of them before, you're definitely going to be in for a treat. 9 plus 16 is the square root of 25, which of course is 5, as I said. And there we go. This one happens to be 36 and 49, which is 85. So this is the square root of 85 is the distance. That is it says is a fully simplified radical expression. So occasionally I'm going to have to simplify my radical expressions. The square root of 85 does not simplify. Is it 85 or 75? Let me do it real quick here. And sorry, 36 and 49. Yeah, I think that's 85. I think that's the right answer. Anyway, I'm going to go ahead and do it one last time, but I'm not going to write the formula. I'm just going to write it in. So I'm going to do the distance is equal to the square root. I'm going to do the y's first. -3, be careful, minus -9. If you have not seen my previous videos in this particular section or any of the others, one of the things that I keep pushing is that if you don't know your integers, if you can't add 2 integers together, you are going to have major issues And it's going to cause you problems all the way through algebra and forever in math, because integers are the basis. Signed numbers are very important. We've got -4 minus 3 quantity squared. And we're looking at the square root. This is going to be 6 squared. If you don't know that 9 plus -3 and why that double negative becomes a positive and why you add it and get 6, you're going to have problems working with this. And I recommend going back and practicing. It will be worth the time, I promise. -4 minus 3 is -7, and we're squaring it. This is the square root of 36 plus 49. And of course, like I said, that is the square root of 85. Now they are going to ask you to reduce this into a simplified radical expression. Now, when I get to the simplification step, I'll go ahead and do that for you and show it to you. There's a lot of stuff going on in this particular section. Personally, I prefer to estimate the distance, which is always nice. And this square root of 85 is between the square root of 81 and the square root of 100. Can everybody see that it's closer to the 81? And hopefully you can see that that's the case, and that these are 4 units apart, and that this whole thing is about 20 units. It's actually 19, but it's close to 20. And 1/5 happens to be 0.2. See if you can figure out where I got the 1/5 from. And so my estimate for this is about 9.2. What I just did is called interpolation, and it's a really important idea in mathematics. It's really good for estimating. So my estimate is about 9.2. The actual distance is exactly the square root of 85 units, and I cannot reduce this radical. And the reason I can't reduce it is because it has no perfect square factors. But anyway, we'll move on. Let's see if they give me a square root symbol. There it is. 5. And looks like we're done with that. Come on. It's like we're moving along pretty quickly. I guess they expect it to take you a while. Now I'm going to do this one in my head. That's going to be 4, 16, and 25 makes 41. So this is the square root of 41. Now, of course, you can do this a little bit faster. Now, the reason that I'm able to do this quickly is that I take the slope in my head, which is the 10 minus 6. Sorry, I said 10 minus 6. Now, I don't actually write it down. I just do it in my head. So 10 minus 6 and 1 over 1 minus 6. And 10 minus 6 is 4. And 1 minus 6 is -5. And yes, the slope is -4/5. But what I use this for is when I take the distance formula says that you take y2 minus y1, which is right there, and square it. And you take x2 minus x1, which is right there, and you square it. And you get the square root of 16 plus 25, and that is the square root of 41. The square root of 41 is between 6 and 7. It's pretty close to the middle, so I would go with 6.5. 6.5 is pretty close, and it's a little bit lower than 6.5, but it's really close. Anyway, square root of 41 cannot be reduced. It is absolutely certain because it just so happens that 41 is a prime number. If you don't know your prime numbers, you might want to look them up. That's a really important concept as well. So this is the square root of 41. And we'll move on. Like I said, I really like these. Okay, so this one is going to be 9 is 81 and 36. Oh man, I'm slow today. 117. So this is the square root of 117 is my distance. We're going to just go ahead and I'm just going to write the distance is the square root of, looks like 8 minus 5 squared. Oh, did I make a mistake? Oh, I sure did. That's not right. It's going to be 9 and 36. Sorry about that. That's going to be the square root of 57, isn't it? I can't subtract today, sorry. Let's see, 36 and 9 is the square root of 47, maybe. That looks right. Okay, so there's the difference in my y's, and here's the difference in my x's, 0 minus 6, quantity squared. And we're looking at the square root of 9, that's 3 squared is 9, and 6 squared is 36, and, oh, geez, I cannot add today. Square root of 45, there it is. I sometimes write down the unreduced slopes so that I can see my squares in my head. Anyway, yeah, that is the square root of 45. Now we have some bad news. You have to reduce the square root of 45. And it's a bit like reducing a fraction. Some of you might know that if you took say 18 over 45, you would be able to reduce that, wouldn't you? Because it has a common factor of 9. And if I divide by 9, I get 2. And if I divide this by 9, I get 5. Now, all I did was divide by the common factor. Now, like I said, this has some things in common with that. When we reduce fractions, we look for the greatest common factor between the numerator and the denominator. For radicals or radical expressions, we look for the biggest perfect square factor. And perfect squares are numbers that we can take the square root of, like 4, 9, 16, 25, 36, 49, 64, and so on. So the number that goes into 45, of course, I did this one on purpose, we can take a 9 out of it. So this is what we do. We say 45 is really 9 times 5, isn't it? And that is the same thing as the square root of 9 times the square root of 5. And I can take the square root of 9, which happens to be 3, square root of 5. A lot of people say, well, why would you want to reduce? Well, in a lot of ways, I reduce for the same reason I reduce this, but there's some other very important reasons for reducing. So anyway, there it is. That is 3 times the square root of 5, or just 3 square root of 5. And we're done. Nothing like making 2 errors on one in my head. Shall I see if I can do this one in my head? That's going to be 64 and 16, which is 80. So this is going to be the square root of 80. Hopefully I didn't mess that up for you. I'm going to go ahead and do the distance is equal to the square root of -1 minus -9. There's that darn double negative messing you up there. Plus, I have 0 minus -4. And we end up with the square root. Now be careful, that double negative means that we're adding. So that's going to be 8 squared is 64. And 4 squared is 16. And when we add those together, sure enough, we get the square root of 80. Now this is almost exactly 9. This is about 8.9 if I were to estimate this. And I'm using my interpolation. Do you see how close it is to the square root of 81? Look at this. The square root of 81 is exactly 9. So the square root of 80 must be pretty close. Anyway, we're not done yet because I still need to reduce my radical. Now, a lot of people are going to say, okay, I'm going to look for a perfect square factor. And they say, oh, well, obviously 1 is a perfect square, but that doesn't help any. It doesn't reduce anything, just like it doesn't for fractions. But what about 4? 4 goes into 80. Hey, there it is. But take a look. 9 doesn't work, but the very next one, 16, goes into 80. And this is where number sense is very helpful. I happen to know that 80 is 16 times 5. Now, some people are going to go through and want to reduce this one piece at a time. You don't want to do that. For example, if I said, I don't know, 8 over, well, let's make it a little less obvious. How about 24 over 80? Now, if you were reducing fractions and you saw that 4 is a common factor, you wouldn't have any trouble. You could divide by 4 and divide by 4, and you would get 24 divided by 4 is 6, and 80 divided by 4 is 20. And then you could say, oh, I could divide by 2 more. So I'm going to divide by 2 and get 3. I'm going to divide by 2 and get 10. So this 3 over 10 is the same as 24 over 80. When we reduce fractions, we can do it one step at a time, but you don't want to do that for your radicals. Some people will do it, but I don't recommend it. You want to look for the biggest perfect square factor. Anyway, there it is. Square root of 16 times 5. Now, eventually, you're going to take out this middle step, and you're not going to see it anymore. I think some teachers start taking this step out too soon, and students need this step for a while. So make sure you include it. This step, most people are going to take out right away. And again, this is one of those steps that some people are going to need for a while, and then eventually they're going to get rid of it. And then that's going to be 4 root 5. That's 4 times the square root of 5, which is the same as the square root of 80. So we're going to put it in. 4 square root of 5. Go. All right, so we've got 100 and looks like 4. So this is the square root of 104, it looks like. And unfortunately, sure enough, that is reducible. You can take the 4 out of the square root of 104, and it happens to be 2 root 26. With a little bit of number sense and a little practice, you could also be able to do this in your head pretty easily. So let's do distance is the square root of the difference in the y's. And I'm just going to make my little arrow this time. It's a little different, kind of different methodology here. 10 minus 0 squared. And here's my 8 minus 10 squared. And remember, the order doesn't matter for distance formula, but it does matter when you're doing the slope. So I recommend that your arrows are always going in the same direction. What this is doing is ensuring that you're taking the difference in the y's and the difference in the x's in the same order. Anyway, that is the square root of 10 squared, which is 100, plus my negative 2 squared, which is 4. And that is the square root of 104. And like I said before, we can take the 4 out, and this is the same as the square root of 4. And I'll go ahead and do all the steps for you, 26. I'm going to eliminate a couple of these steps now. 4 times the square root of 26, which of course is my 2 root 26. A lot of people are going to be concerned because they're going to say, well, what about 26? 2 goes into 26, and so does 13, but neither one of those is a perfect square. So we've reduced this as far as we can. 2 root 26. And what do we have here? It looks like we're looking at 9 and 4, which is the square root of 13. Nice and easy. All I did was take my slope kind of in my head. The slope is -1 minus -4 over 0 minus -2. This happens to be 3 over 2. Now that is the slope, and it's unreduced. You never want to reduce it. Now, if I square the numerator, unreduced, and square the denominator and add them together, I have basically the distance formula. The distance formula is y2 minus y1 squared. That's my 3 squared. And x2 minus x1 squared, which is the 2 squared. And the square root of 9 plus 4 is the square root of 13. It just so happens that, you guessed it, 13 is a prime number. There's no reducing it, and you're all done. Can you tell where this number is? It's between 4 and 5. See if you can figure out where I'm getting that. Sorry, between 3 and 4. My bad. It's between 3 and 4 because the square root of 9 is 3 and the square root of 16 is 4. And it's pretty close to the middle. So 3.5 is a good estimate for this. Anyway, it's a little tiny bit closer to 16 than it is to 9, but you know, it's a good estimate. Anyway, square root of 13, there it is. And hopefully my shortcut saved you enough time that all the extra instruction will be worth it for you. This is going to be square root of 5, isn't it? Can you see it? I took the 1 and squared it. I took the 2 and squared it, and I added them together, and yada, yada, yada. It's the square root of 5. No reducing. Okay. Shall we just finish it? All right, I'll write it. Distance equals the square root. 10 minus 9 is 1. 2 minus 4 is negative 2. I'm going to go ahead and write the negative 2 squared. That is the square root of 1 plus 4, which is the square root of 5. A little more than 2. Anyway, there it is, square root of 5. What I'm hoping is you guys will like these. Hopefully it didn't take you too long to learn them. Looks like we're looking at, 15. Can you square 15? It's 225. And negative 8 minus 7 is just 1. So it looks like we're looking at the square root of 226. I don't think it has any perfect square factors because 4 doesn't go into 226. No really nice factors that I can think of. That's 2 and 113. And I do believe that 113 might just be a prime. So it looks like we're pretty much done at that point. The square root of 226 is probably the only one we want. And it's a little tiny bit bigger than 15 because 15 squared is 225. Anyway, I'm going to go ahead and write the distance is the square root of, this is negative 15 squared, if you want to see the pieces. And it looks like we have a negative 8 minus negative 7, which is negative 1 squared. And that is my 225 plus 1, which is the square root of 226. And as I said, that can't be reduced. And it's approximately 15 units. It's just a little tiny bit bigger. Looks like that's it. What else do we have? Looks like we have 25 and 36, which is the square root of 41, I believe. Oh no, 51, huh? Ooh, ouch. Yeah, 36 and 25, 36 and 25. How come I can't add today? I don't know. Anyway, that's 61, isn't it? So the square root of 61. 61 happens to be a prime. If you're wondering where I got the 36, that is the distance is equal to the square root of the difference in the y's, which is 5, negative 5 actually, if I subtract in that order, squared. And 10 minus 4 is 6 squared. And that is the square root of 25 plus 36. And that is the square root of 61. And we're all done because 61 is a prime. You need to know those prime numbers. Makes it easy so you don't have to be looking for factors all the time. So square root of 61. And it looks like we're done. And this one has a difference of 2. And this one has a difference of 14. 196 and 4 makes 200. Now 200 is one of those weird ones that's really easy to take the square root of. The square root of 200, or reduce the radical, sorry. The square root of 200 is 100 times 2. So this is the square root of 110, root 2. I said 2. What's wrong with me today? Come on. There we go. root 2. So this is the reduced version. And let me show you why we used to do reducing. It was a really dumb reason. On our calculators, we didn't have a little square root key. So what we did is we had to memorize the square roots. And we would memorize the square roots of the primes. So I knew the square root of 2 was 1.414. And there's some more. I used to know it to like 5 or 6 places. And then I would just multiply that number by 10, which happens to be 14.14 approximately. And that's how, if I didn't feel like doing interpolation, I could get my estimate. Anyway, when you don't have a square root on your calculator, it makes it a little more interesting. So let's go ahead and do the little steps for you. A distance is the square root. We've got -5 minus 7, which is 2 quantity squared. And 7 minus -7 is 14 squared. And that is the square root of 4 plus 169, 196. Yep. And that is the square root of 200. If you want to see the steps, it's the square root of 100 times 2, which is the square root of 100 times the square root of 2, which is 10 root 2. Be careful. A lot of students start skipping this step and this step a little too early, and then they have problems with reducing the radicals. So there's your radical expression, 10 root 2. And this one looks like we've got 11, which is 121. I'm just going to write that down. And 49, which is the square root of 170, isn't it? There, I put all my work too. Hopefully you'll not need much more than that. I'm hoping you guys can get this. Anyway, distance is of course the square root of that is -6 minus 5, which is -11. Do you see where the integers come in? I hope you can. Hopefully you'll understand that you really need to know your integers. And we're going to add the 3 minus 10. Oh, sorry, I was just going to put the answer there. 3 minus 10 is -7. And notice we have 2 negatives there. So if I were to take the slope of these two, it ends up being a positive slope. It ends up being 11 over 7. Because -11 over -7 is 11 over 7. That is the square root of 121 plus 49, which happens to be the square root of 170. Now, a lot of people are going to go, oh, wait a minute. I can take a 5 and put it into 170. And sure enough, 5 is a factor. And so is 10. 10 and 17. You all have probably seen a factor tree. A really good way of looking for reducing your radical is to take a factor tree. If you've never heard of a factor tree, this is what it looks like, something like this. And then 2 times 5. And these are all prime numbers, 2 times 5 times 17, which is called the prime factorization of 170. Now, the reason for doing a factor tree is we're looking for pairs of factors, because if you have a pair of factors, you can take them out of the radical because they happen to be a perfect square factor. Now, I'm going to give you the sick little trick that I used to teach to my 7th graders. They're going to take the pairs out of the sock drawer, right? You don't take out a single sock. You take out the pairs and you put them together. So anyway, the 170 has no pairs in the sock drawer, so you can't take any out. Anyway, there it is, square root of 170. And we're moving on. And what have we got? Almost finished, right, guys? Let's see. Oh my goodness, it took too long. Oh, don't kick me out now. I want to do my last one. Oh well, looks like I'm getting a sit and spin kind of situation here. Looks like I'm losing my My deal. Yeah, bad connection error. So anyway, I got to 98. I hope you guys will continue and practice and do your own, and hopefully you get some insight today. And I will see you back, hopefully. Bye.